The sun is going crazy right now. We have huge energy increases apparently in the Schumann resonances, and so we're going to look at everything in today's video. I'll give you my best interpretation and breakdown as to what's occurring. Can't guarantee that this is going to be 100% absolutely accurate because the world is an amazing place with full of things that we don't know, but I will apply my geophysical expertise and my intuition as to what's happening right now to give you a breakdown energetically and also a forecast for what's to come, because we had an X 1.11 flare today. That's the highest designation in X flare from the sun. We're in solar maximum, and that launched a coronal mass ejection, which is pretty clearly headed our way. Most of it to the south, but definitely some of it heading our way. I did not brush my hair, but we are ready to go. Massive energy surge. Here's our sun in 304 and 195 angstrom views. And if I step off, just you can see how crazy it's been. And this doesn't include the last like 3 hours of data. But we can see that it's not just one spot, though this one in particular has been extremely active. It's all over the sun. They're all going bonkers right now, and they're all working together sympathetically. So hello everyone, I see you all in the chat. Thank you for being here in the live stream. We will again go down every single rabbit hole, talk about everything. We'll do a question and answer too. Save your questions for the end, and please don't spam them. And keep them on topic and relevant to what's happening here. Don't like, oh, I want some information specifically about myself. We're talking about the greater energies here. So please, thank you so much. Okay, let us go into what's been happening with the sun first and foremost, because that is what's really been dramatic over the past not even 24 hours. Here we have our most recent SUVI imagery. This also doesn't have like the past 3 hours. I have a separate video for that. But we can see that 1.11 X-class flare right there. But just look how active it's been. I mean, it's going absolutely bonkers everywhere across the sun. And we do have a coronal mass ejection pushed out from that. We have certainly a lot of energy headed our way from this. The initial forecast for this impact is the very end of the year, December 31st. So we were wondering whether we were going to have something come in. Everything was missing us. I made that video 2 days ago about how everything was missing us. This is a new phase of solar activity. Let me switch over really quick to my display capture and show you exactly what I mean. Here we have our, oh, not that one. Here we have our, here we go, our X-ray flux for the past 3 days. And we are still in an R1 radiation right now because a radio blackout, because we've had this big increase of energy and we're still well up in the high M class range at this moment in time. So that's why I'm going live, because we had this 1.11 X class flare and then this M class flare. I started making the video on that one, and then, well, it's just continuing. So let's just see where it goes live together. But look at this explosion that's occurred. Here we have the past 3 days. Yeah, we've had some stuff, but pretty low. And now look at our levels. They've dramatically increased. And if we go to our 2-week view, then you can really see what I'm talking about as well. Here's our 2-week view. And so we see that we've been on this slow uptick and uptrend, just going like this, now culminating with this 1.11 X class flare, a 7.1 M class flare, a 3.3 M class flare, and I don't even know the strength of the most recent one because it's happening right now as we're speaking. It is a 3.3 as well, it looks like. So really insane. We can actually go to our most recent imagery here and give that a look live, because it's happening right now. Here is the group that it's from. Let me get this started for you all. And this is the live feed from the GOOS satellite right now. And yeah, again, look at this. It's just all over the sun. It's not isolated to just one single spot. That was the 3.3 M class flare that we had just before this one then started to flare. A whole bunch of sympathetic flares. So they've been working together. And that's not unheard of. but it has been kind of bizarre how there's been so many of them now for quite a few days. And usually you have like this solar flux push out from one spot, like this one right there. Look, I mean, we have the sunspot, it flares out, boom, like this. But right now we're getting all these working together. It's just like the sun was in this quiescent period at the beginning of December, and then it just exploded now with a complete solar push of energy out towards us. We are right now here, right? This is Earth facing side of the sun. So we are effectively right here. Of course, we're 1 astronomical unit away, but all this activity is happening directly in front of the Earth. It's not happening on the far side or, you know, on this kind of angle. It's all basically happening right in front of us. So we're front row seats at the Taylor Swift concert, basically. And this is just going absolutely bonkers. And the question is, how much of this energy is going to be headed towards us? That is the big question. So let me go back. Well, let's look at that X flare one more time. Boom shakalaka, look at that. But really, boom shakalakas across the entire sun. I mean, it's not like we've never seen this before, but this is a big day of solar activity. Important to keep in mind, we have a new moon tomorrow. And there is data that shows that the occurrence of geomagnetic disturbances is lowest on the full moon, on the new moon. And so it is interesting that right now we have this huge amount of energy being pumped off the sun. The sun is just losing it. Yet, typically, across long data sets, we have the least amount of geomagnetic disturbance on a new moon. So it's going to be interesting to see how those two kind of work together, like how they mediate each other, because a new moon position in front of the Earth often blocks these geomagnetic disturbances from occurring, but we have this big push of energy coming in right after the new moon on the 31st. So it's going to be interesting to see how this evolves. Let me put on our recent models. Let's look first off at this 1.11 angel numbers, our 1.11 X flare here with our NASA model shooting off. It came off of this side of the sun, but it looks like it's kind of going off at this direction according to NASA. But we do see pretty much a solid impact there looking down on our ecliptic plane. So this is the sun here. There's the Earth in yellow. We're looking down on the solar system. West, east, we're here 0 degrees. Here is our north-south view. So we have north, we have south, and we see it propagate out like this. And so a good chunk of it is heading here to the south, but again, we're hitting the meat of that wave right there. We see the plasma density. It goes from like the blues and the greens to the yellows to the reds and the whites, and we're definitely hitting that peak plasma density as well, according to this NASA space weather model, which is not 100% reflective of reality. Of course, it's just a model. We have to keep that in mind, especially now in the 2020s where everyone's relying on models for everything, and we're going down a crazy path where we're ignoring reality as it actually is. This is just a model. But we can actually look at the chronograph imagery too. So let me actually, we'll go here for that because we have the most recent chronograph imagery on our NOAA Space Weather Portal. So here we are with this, and I'm going to get this set up so it looks all nice for you guys. Yeah. Okay, here, and let me move the mouse. Here we have our last 24 hours with our C3 chronograph, and we will see this coronal mass ejection from that X1.11 flare right there. So this is not as significant as the coronal mass ejection we had on the far side on the 17th, but still a nice push of energy out like that. We see most of it go here, but we see the shock wave go out in all directions. That's just what we have thus far. This chronograph always lags behind a little bit in terms of what we're seeing with an X flare, because it takes some time for that energy, if it does get pushed out from the corona, it takes some time for it to propagate out into view of the C3 chronograph. This is 32 solar radii across. And then it also just has a little bit of a data lag to it. So this is just the most recent coronal mass ejection, the X1.11. But if you notice, there's also some other pushes of energy before that. So we're starting to get a sequence now of energy being pushed off the sun. You see the first one right there, a second one right there, and here is that X1.11. That's the faster one. So we already have a pile up of 3 of these coronal mass ejections now headed our way, with more solar flares occurring at this moment in time. So yeah, things are getting pretty wild. We can look at our SUVI imagery recent right here. This does not show the 3.3 M-class flare that's occurring right now. This shows everything before, but look at that push right there. That's basically Earth center direct, just slightly off of that zone. Definitely could be geo-effective. We have some pushes up here that's occurring right now. So the whole sun, again, is super active. And a lot of people ask the question of like, why does this matter? Well, the sun is our central engine of energy for our entire solar system. If you were to remove the sun and nothing else changes, like gravity, whatever, right? If you were to remove the sun, the Earth would all of a sudden become a frozen wasteland. And almost certainly we would all die unless we had like nuclear bunkers or something, right? Then you could create your own light and your own heat and everything. But without the sun, things are not good on this planet. So we see changes in Earth's energies geophysically with changes in the sun on different time scales. You have long period variations like solar cycles, which is about a 12-year cycle. You have even longer ones like Gleisberg cycles and even longer period variations in solar activity that we're still learning about. And then you have shorter term variations like what's happening right now, where we're getting this huge increase in energy. And so when you have more energy coming off from the sun and reaching Earth, that in general charges the Earth. Now we can think of this for the like energetic implications of how does this change our weather, which it interacts with our weather systems via the global electric circuit in the ionosphere. How does this change some of the technological things that are important to us, like radio communication and satellites in space? When you have a big solar storm impact, it can cause drag on satellites and cause them to re-entry and burn up, right? Cause GPS dysregulation during the May Mother's Day storm in 2024. So back in about May 10th to the 12th, farmers were having a terrible time with their tractors because GPS signals were just going totally bonkers. So there's real world like implications for all this. And then you also have the connection between, for example, earthquakes and solar storms. That one's quite interesting. I mean, I think I have this graphic on my computer pretty readily accessible. So let me pull it up because I get some people saying there's no connection between them and they just simply haven't looked at the data because it's really pretty fascinating, the connection between earthquakes and solar activity. Oh my God, where are you? But we have this, basically what happens is when you have solar energy coming in, you have this loading of energy into the Earth, right? And then as that pulls away, you all of a sudden have this explosion of earthquakes. And it's in a different folder. One moment, folks. Because I do want to show this. This is important. Because earthquakes are one of the most energetic processes that occur on our planet. So it's pretty important to understand the connection. And here it is right here. And okay, so here is some recent data going back to solar cycle 21, and we see sunspots, and then we see in this top graphic earthquakes greater than or equal to magnitude 7.8, and then the bottom graphic earthquakes greater than or equal to magnitude 8.3. So you see during solar maximum, just right off the bat, here colored in by these orange bars, we don't have that many earthquakes. Sometimes you do, but in general, most earthquakes occur during these solar minimum phases, especially with the great earthquakes, right? Here, none. Yeah, we get one there, we get a few here. Now, what's so interesting about this data set is it also shows a longer term variation in solar activity. So we had solar cycle 21, stronger than 22, which was stronger than 23. 24 was anomalously weak, and so we had this long period of solar forcing. If we go all the way back to the early 1900s with solar cycle 19 as the peak back in the mid to late 50s, this was starting to descend then, And once we had this anomalously weak solar cycle here, which was the last one, solar cycle 24, look at the explosion of earthquakes that we had and the explosion of big earthquakes. So now we're in solar cycle 25. Solar energy is loading up again. We've had some big earthquakes that have occurred during some of these periods where solar activity is pulled off into shorter term variation, but we see this clear connection between solar energy loading and then the Earth responding once it's pulled back with some big earthquakes, that energy getting pushed out. So that's another real world application and understanding of how solar energy affects us. We also, I passed this graphic when I was looking for the other one just now. Let's talk about this for a moment, because it also is more than just the geophysics of the planet. We could connect that to volcanoes as well, though that connection is a little bit more tenuous, needs to be explored more. But we also have this relationship between solar activity and spontaneous social processes. So here we have solar activity, Wolf number, basically sunspots. This is like the yearly sunspot count average, going all the way back to 1750 and going up to solar cycle 24 here. Doesn't show 25 yet because this is from a research paper. But look at all the things that have occurred during solar maximum periods, denoted by these high marks there. So really, like when you have a lot of solar energy coming in, charging our system, us as receivers of that, we're also receivers of consciousness, just as much as we're transmitters of consciousness and recipients, and like we are our own conscious beings. I think humanity needs to wake up to the fact that we are very much receptive and imprinted by the consciousness around us. Others, life in general, the sun, the solar system, the cosmos. So when we have all this energy coming in, look at all the spontaneous social processes that occur. American Revolution, there with solar cycle 3, one of the strongest that we've had. French Revolution, a whole bunch of revolutions in Europe there in the mid 1800s, and then the Russian Revolution, the first one, then the second one, Spanish Civil War. People's Republic of China was founded, right? A whole bunch of stuff. So basically, it's just a recognition of the fact that because the sun is the central engine of life and energy in our solar system, we of course respond to that in a multitude of ways. Earth does so energetically with the global electric circuit, things like the Schumann resonances, which right now are going bonkers, and also our own societal processes, our own consciousness, and that is basically what's happening right now. We're having this huge energy explosion. So let us look at, I have some more data for you guys. Let's look at the NOAA model, and I want to get to the Schumann resonances in just a little bit. And I'm just going to show you the data on them actually fast, really quickly. Here we have the Schumann resonances out of Tomsk, Russia. So we see this big energy wave coming in here. We're going to look at this data plus more because there's quite a few different stations now that I have access to that show us the background electromagnetic field, which overlaps with our brain waves and our heart rhythms and more. And so we are going to talk about this because it's interesting that we have this big explosion in solar activity right as we're also having these apparent increases in the Schumann resonances. But going back to our NOAA space weather model so we can understand the impact of that coronal mass ejection that was launched. Thank you, Mandy, for the super thanks. Here we have what NOAA's put out. They're certainly going to have to update this because, again, solar activity right now is just so bonkers. We're going to have to check that again soon because I'm sure we have a new M flare or something. But here we see this big wave of plasma propagate out. Again, this is looking down on the ecliptic plane. That's the sun. This is the Earth. We're looking top down. Here we have our south-north view. So this is kind of a cut across. Here's the Earth. There's the sun. We see this plasma wave propagate out. Some of it here to the south, but still we get hit with a nice chunk of high-density plasma there. According to NOAA, on the 31st of December, this is universal time. So this could be a little bit earlier. I think it's probably going to be on the 31st. I actually think that this is probably a little bit too early. It's probably going to be a little bit later in the day. But we also see this big increase in the velocity. Here we're looking at solar wind velocity. We will see this coronal mass ejection propagate out. The colors will go up into the reds, showing a pretty high velocity, actually even to the whites. and then we get hit more on the edge of that coronal mass ejection according to this NOAA model. Again, not 100% reflective of what is going to occur. NOAA has released new WSA model prediction. Okay, let's check it out. I just have to pull it up. Yeah, I'm sure they're working overtime right now. And then we just go to display capture here. Here is a new, thank you for mentioning that. Here's our new NOAA model. And we just get this set up for everybody. Let us give this a look. Here's the new NOAA model. All right, let's go. More severe, and according to them, we are being hit with the peak of that plasma wave. Look at that right there, even maintaining as it goes out. So let's watch this one more time. Keep a view here. I mean, we'll talk about this. The velocity there, high velocity impact. Most of the plasma density in this north-south is going just below us, but here it's hitting us. So we are getting basically hit perfectly by that coronal mass ejection. They are expecting the plasma density to spike up to 50. This number typically isn't accurate, but it does reflect the fact that we had that compression wave coming in, and they expect velocity to go up to 700. Again, they've pushed this a little bit back later on the 31st. So that's more in line with what I was thinking. But we will see when that occurs. I think it's probably more going to be like here. But again, in about 48 to 72 hours, we have this coming in, and almost certainly more. Because we can look at, again, what the sun has been doing. Here's our X-ray flux. Again, this is today. There's like more than 16 M-class flares here. I counted them out when we were like over here. But if we punch into the 1 day, we have basically each one of these little spikes is an M-class flare, because the X-ray flux has been over the M-class territory the entire time. So I got up to like 15 or 16, and now we've had some more. Most recently, this guy right there, which now looks like it's coming to a close, and that is a 3.33. Another 3 point, a lot of angel numbers. 1.11, 3.33. We've had two 3.3s. David Walker, thank you for the super thanks. So lots of M-class flares. One big X-class flare. Let's again go back to, I do want the chronograph, but let's go back first off to our SUVI to see how that most recent 3.3 flare has done. And we punch in on this. Yeah, that looks good. Let's give this a look. Move the cursor off. So yeah, our most recent flare is from this group right there. And what's interesting actually about all this activity is that this sunspot group here has been quiet. 3, 9, 3, 8, which is the one that's been the most active before this occurred. So we had this guy to thank for that far side coronal mass ejection, which was super fast in velocity, was of a Carrington class, you could say. You can make that argument. And then we had a whole bunch of M-class flares from it, sympathetically working with others. Now it's been quiet. These guys have gone bonkers, and it's just now entering into the strike zone. Almost like the trumpets in the parade as the king is like approaching his castle, and he's calm and regal. And we'll see if 3.9, 3.8 does anything. But again, this is just like the past 3 hours or so from the SUVI. We're not looking at like 24 hours here, but just look at how much has occurred just in the past 3 hours with our 131 angstrom view. Why do we feel these solar flares? Well, it depends on your own individual connection to subtle energies and also your own bioelectric status. So if you, if you're really robust and you're in really good health, then you might not feel these so much in a negative way. You may just feel an enhancement of your energy. For example, sometimes during like solar storm impacts or a big solar flare, like I'll go off to the gym and I'll have like a great workout. Like I'll be really pumped up. But sometimes if you're a little stressed out, it can cause inflammation or pain, or it's just like overloading the system, your nervous system, because it's our nervous system that connects to these subtle energies the most. Our autonomic nervous system, sympathetic, parasympathetic, right? Stress or rest. And so it can disrupt your sleep, and it can just in general kind of cause your biorhythms to get out of phase. Your circadian rhythm gets thrown off. It depends though on your connection to these subtle energies, and very much depends on if you're focusing on them. If you're totally oblivious to stuff, you're probably not going to feel it so much. But if you're not oblivious, then you're going to develop that resonance with these things. So a lot happening right now. Let's go to our chronograph just to see what's been happening most recently with our C2 chronograph view here, because I'm sure there's been some recent pushes of energy that would be worth talking about. Let's give it a look. That's that 1.11 X-class flare, and yeah, we got some more coming off too. So a lot happening right now. I mean, this video, we may get like more X-class flares in just the next few hours or a couple days. Very possible. This could be a launch pad for some really intense solar activity. I may have to jump on and do a video or a live stream again before I know it, because again, if we go to our X-ray flux here, and we punch out to, let's punch out to 7 days and go like this. We can see that we've just been charging up like this, and this really could even just be a launch pad for something bigger. We can't discount that possibility. Right now, it definitely is a climax moment, but it doesn't mean it's the final one. It could be another push of solar energy on top of this. We have that sunspot group 3938 rotating into the strike zone, which has historically, before today, been the more active sunspot group. Here we have our most recent sunspots. Whew. Look at this. Now, the reason why 3936 has been so active and gave us that 1.11 X-class flares, look at it. That guy's a monster. I mean, it's really been growing, evolving. It is quite, it's not the friendliest looking sunspot. And all these here are actually quite big and significant. 3939 has been starting to become active. It's been growing. Here's 3938. So it's a little bit behind this graphic here, but again, it's just about to enter that strike zone. And the important thing to keep in mind here is that for the past 6 months or so, we've had a lot of activity in the southern hemisphere. This now is signaling a change in sunspot distribution, because now we have a whole bunch happening in the northern hemisphere, and honestly, these are the more significant ones, 3936, 3938. 3938 is also pretty high up. And so what happens during solar maximum is you get these sunspots, and they start off at these like kind of low, these high to mid latitudes. And as the solar cycle progresses, they get closer to the equator until eventually the magnetic flux defined by each of these sunspot bands, they meet each other and they terminate. And then you have this new solar cycle that starts. And that's effectively because the magnetic field is flipping, right? You have the, get my hands aligned. You have the magnetic field flipping. So when you have sunspots higher up or lower down here, right? More in the high latitude regions, that's a signal that you still have solar flux being pushed up closer to the poles, indicating that you're still closer to the beginning of a solar cycle than you are towards the end. Now here we have a whole bunch here pretty close to the equator, right? So looks like the flux in the southern hemisphere is a little bit more progressed along with that cycle, but in the northern hemisphere, this one's still, mid-latitude. So we still have some time to go in this solar cycle. You can look at that and get a sense of it by looking at the actual position of these sunspots. So when you get a sunspot group that pops up way up top or way down here, that's kind of a sign that, hey, things are still early. We have been having that. This one, 3938, really shows that. But again, just in general, solar cycle 25, 2025, into 2026, and then the descending phase. And actually a lot of solar storm impacts come during the descending phase. So we're looking all the way till 2028 until solar activity starts calming down, really. Thank you, Rootseller, for the super thanks. Is there any way to tell if our BZ levels will be north or south during the CME impact? There's just one thing that we can do. What Rootseller is talking about is, okay, well, we can have a coronal mass ejection come in, but is it actually going to connect to Earth's magnetic field? And we have our own magnetic field, which has a predominant northward component until Earth's magnetic field flips, which could be hundreds of thousands of years or millions of years, it depends. Until that flips, our component direction is BZ positive. So we need a BZ negative from the solar wind to have a strong connection between the solar wind and Earth's magnetic field, and therefore a geomagnetic storm. And so if we look, for example, right now with our solar wind, we see that this red line there, representative of the vertical BZ component. B stands for magnetic field, Z is a Z component. It's positive 2. If this goes really sharply down here, then we have a big geomagnetic storm. Now what occurred, we go to our 30-day, what occurred about 2 weeks ago is that we had a surprise impact. This was the plasma blob I talked about, which everyone didn't think was coming, though I made a prediction for it. This was extremely strong. Actually, if we zoom in on this, I mean, check this out. This could have been a big storm. We see that the plasma velocity went up, the density, had a lot of turbulence, the temperature went up. Thank you, lightning in a bottle, for the super thanks. And our interplanetary magnetic field went up to over 30, but we did not have a big storm from that, only a G1, because the BZ component was sharply positive. It was 24 right there, right? See how it jumped up and over? That meant that it did not connect to Earth's magnetic field easily, and most of the energy kind of brushed off just around the planet, around our magnetic shield. There's only one real way to tell if we are going to have a solar storm impact that's quite significant. And it's just because right now we are lucky in our location of the solar orbiter probe. I'm looking for that data, one moment. We have a solar orbiter probe right now that's roughly in line with the sun and the Earth. And here we go. Oh, not that one, sorry. Display capture, here we go. We have a solar orbiter probe that's roughly in line with the sun and the Earth. And as a result of that, it is upstream of us and basically gives us a heads up as to what type of magnetic field is coming our way. It's 0.2 astronomical units upstream. Again, sun to Earth is about 1 astronomical unit. So we can look at this data to get a sense of what we have coming in. Here it actually records a bit of a shock to the solar wind. Looks like we had a dropout just recently. And so this gives us just a little bit of a heads up, just barely, maybe 8 hours or less. It depends on the velocity. This can give us a sense of that though. This is solar orbiter probe. You can just type in latest solar orbiter magnetic field data on Google and you'll get this link. Beyond that though, this right here is collected by the satellite at the Discover satellite at L1, which is the L1 Lagrange point, 1% of the distance to the sun. This gives us about a 1 hour heads up. So what we see here takes about an hour to actually reach us. That's all we got. So, I mean, it's a lot of research and work to do all this yourself. And so if you'd like to stay appraised, you can subscribe to the channel. I'm definitely going to be keeping everyone up to date as to what is happening over the next few days, because this is a very active situation, and not just with the sun, also very active with things like our Schumann resonances. We see this big explosion in the energy with them. Let's talk about that a little bit now, because this is also a very active development that's occurring right now that has a lot of people's attention, and a lot of people are feeling this. And that's the thing, it's the combination right now of the two of them that is really, really significant. So we can go here. Here we have our recent Schumann resonances data. This is our vertical electric field spectrogram out of Tomsk, Russia, going from 0 to 40 hertz. And effectively we're measuring the vibrations going from the ground surface up to the ionosphere, these little vibrations that exist in our atmosphere electrically. Here we're measuring the strength of them. This is the amplitude of this data. Thank you, Patty, for the super thanks, and for everyone that signed up for the Soul Tribe. So we have the amplitude of these different Schumann modes. Here we can see the Schumann resonances. This is the entire background vertical electric field from 0 to 40 hertz. The Schumann resonances are these bands of increased power that propagate out across time. So we have mode 1 there, 7.8 hertz, mode 2, 14 hertz, mode 3, 20 hertz, mode 4, 25 hertz, mode 3 is a little further down at 33 hertz, then 39 is mode 6, and so on and so forth. We have more data sets than just this one to look at, and we will do that. But the reason why these are so interesting is that they overlap with our biology in a multitude of ways, not only just in terms of our brainwaves. Our brainwaves have the same frequency structure, 0 to 40 hertz or beyond, but also the same power density, both in the magnetic field and the electric field. Also, our heart rhythms and our autonomic nervous system overlaps with this part of the light spectrum, and therefore Schumann resonances. And we see Schumann resonances connect to effectively cellular and molecular functions happening within the body. Because even though these are subtle fields, they have an ability to move electrons, because electrons are extremely low mass, 1,800 times less mass than a proton. So a subtle vibration can still shift and move where an electron is kind of resonating and vibrating, which can trigger conformational changes within proteins and ion channels and unlock ion channels, and therefore change larger cellular voltage gradients, which we know influence, for example, the expression of DNA. And it can even move electrons within DNA itself, which is highly conductive. It's a fractal antenna. So these electrons that are embedded within DNA and fascia, and our entire body is bioelectric. These fields are still strong enough to influence that at that level, which then has these ways of propagating up in its characteristics. So then it can influence cell behavior. There's been a lot of research done on Schumann resonances and inducing cellular apoptosis, so pre-programmed cell death. Thank you, Yuri, for the super thanks. Thank you so much. And so they do have an effect, but at the most basic, they overlap with our brain waves and our heart rhythms and our autonomic nervous system. And they are very much, and I believe, and there's evidence for this quite a bit, that they act as a collective consciousness and an information network that we all connect to. And just as I mentioned at the beginning of the video, how we are, as much as we are carriers of consciousness ourselves and we have our own, we are also very much just like receivers of consciousness. And a lot of our day-to-day, I don't think people recognize how much of that is actually in that receptive mode. It's kind of an unconscious receptivity to others and their actions, their thoughts, their behaviors. Of course, everyone knows the phrase of like, you are the amalgamation of the 5 people that you're closest to. And everyone has their own consciousness. So yeah, it's very important to be mindful of like your environment, who you're with, all this stuff. The Schumann resonances are like an energy information network that carries all that collectively together, created by the Earth geophysically, lightning strikes, solar radiation hitting the global electric circuit, a whole bunch of things. Earthquakes create Schumann resonances. You can even have Schumann resonances embedded within coronal mass ejections, because these are just vibrations at these frequencies, 7.8 hertz, 14 hertz, 20 hertz. So anything that's vibrating at that frequency technically is a Schumann resonance. It resonates on Earth because it matches Earth's physical dimensions. The circumference is a certain size around the Earth. The Earth isn't, getting bloated after every single meal. It stays the same basically. And so you have these frequencies of light that are very stable and they propagate continuously. We see that nicely here. But then what do we see after that? We see this massive power increase, because here is our power legend. We see that blue and like indigo is low and then goes up to red and white. It's increasing in power. We see that with our amplitudes for the first 4 modes. Mode 1, mode 2, mode 3, mode 4, all of them increasing in amplitude. And the weather right now in Tomsk is just haze. That's what it says. It says it's just haze. Thank you, Wilderama, for the super thanks. So we have this increase happening in the power level of the background vertical electric field, the Schumann resonances, out of Tomsk, Russia. Now that's not going to be the case everywhere, and it actually is not. If we go to our latest data out of Cumiana, Italy, we will see that the Schumann resonances here don't have the same exactly look, you could say. We see mode 1 there, 2, 3, 4, 5, 6. We see all of them kind of bleeding up. But if you are well aware of looking at this data, like you've done it quite a bit research into it, you can see that this is in general a higher power density than normal as well. And actually we see that really nicely here with this graphic. Let's punch in on that separately. Oh, not that. Here we have our 7 days or 6 days of Schumann resonances data out of Kumiana. And so we see the power density of them. Look at how the colors are fainter over here. Look at today though. Big increase in power density in the Schumann resonances. So this is out of Italy, pretty much showing what's occurring also out of Tomsk, Russia. So we have this occurring in multiple places. And I can also show you the data out of the British Isles. I found a new data source, which is lovely. Now this is for yesterday. Thank you, Becky, for the super thanks. Here we have some Schumann resonances and geoelectric field data for the British Isles. And this is for yesterday. This is not a live data feed, but they publish their spectrograms for the north-south channel and the east-west channel every single day for the day that just occurred. So we see our Schumann resonances here, and here it's even easier to see. We see these really discrete bands and lines. What's interesting about this data from yesterday is the waviness right here in mode 2 and how it's bleeding together with mode 3 in general, showing that power amplification, even yesterday. That data from Tomsk was for 3 days. Here, this is just for yesterday. But we see our power density. This is the magnetic field. These are using induction coils. We see this is picotesla squared per hertz. And we see this kind of increase in general there. This time right here is when the Schumann resonances locally in the British Isles are going to be the weakest because the sun is radiating the Pacific Ocean. There's less lightning strikes over the ocean. So you get this decrease in the Schumann resonances anytime the sun is mostly radiating the Pacific Ocean, because again, there's just not that many storms. But then we see this increase as it then starts to hit other landforms. You know, Australia, Southeast Asia, then it starts to go over Europe and everything. But then it's maintained, which is interesting. So the other interesting thing with this data set, this is recent data right here, is that the geoelectric field for the British Isles has been increasing as well. We see our geoelectric field right there, and I'm not sure I can zoom in on this image. I don't think I can with the way I have it set up. But we have our normal variations there. Look at the east-west component. All of a sudden, a huge increase in the geoelectric field, showing that there's just more energy and vibration in the actual crust of the Earth for the British Isles. And then here's our data for today. The range has changed a little bit, but keep in mind that basically this picks up where that left off. And then we see this further increase in that geoelectric field, not only for this component, but also for this one as well. So the Earth itself is vibrating to a greater degree now as well for the British Isles. And so this hasn't looked everywhere across the globe. We looked at Russia, we looked at Italy, and we looked at the British Isles. But for all of these, we see these increases in the background powers, just more resonance, more vibration. And we even see, for example, like the frequency here for mode 2 increasing and then starting to bleed together with mode 3. Thank you for the super thanks, Tammy. So yeah, some really, really fascinating stuff occurring at this moment in time. It's all, in many ways, being driven by the sun. Here we have our most recent data for solar radio flux. The sun emits light across the entire light spectrum. It's not just visible light, infrared, and ultraviolet light. It's also extreme ultraviolet, it's X-ray light, it's sometimes gamma ray light from the most powerful solar flares. That's what we were measuring with these, these solar flares, is the X-ray radiation coming off of them. But it's also radio frequency energy. So, sub-infrared, you have microwave, this is a microwave, 2000 hertz, megahertz, radio flux wave that's emitted from the sun. And we have November here, going from November 18th to yesterday, December 28th. So this is a little bit backwards. It's a bug in this data. They talk about that on their webpage. But we see that we had this spike here, the end of November. We see that sunspot spike right off the frame here with our sunspots. Then solar flux went down. That's right here. And then look at where we are now. It's been charging up. Sunspots have been charging up, and solar flux is over 260, which is incredibly high because of all these sunspots here on the Earth facing side. This is the Earth side of the sun using our GONG network. And we can see other sunspots that exist on the far side of the sun. They have 3 of them now circled. So not only is the Earth facing side of the sun, as we've been looking at, just been exploding with energy and solar disturbances and magnetic flux and explosions and everything, boom shakalakas. But we've also had just recently another kind of push of energy also on the far side of the sun. So the entire sun right now is just kind of pushing out energy like this. We see that very clearly with our solar radial flux, not only reaching this high, but then maintaining that value across time. I reported on it when we had this number there. I think that's the 21st or 24th. Maybe that's Christmas. And then it's maintained. Whereas here, look, went up and then started to go back down. You get normally these rhythmic cycles with solar activity, sunspots, solar flux, these waves, these variations like this. This time, though, it's just been maintaining itself across the entire time. So what we are seeing, and I want to go back to some of our recent data. We can go to make it more visually appealing for everybody. See what's been happening with the sun itself. Yeah, this is nice. So we've been having this huge push of solar energy from our sun, really exploding just today, but there's been a big ramp up now for 2 weeks. We're seeing the Earth energies respond, like the Schumann resonances. This is our background vertical electric field in the atmosphere, all of a sudden starting to resonate more, which means that they're also resonating to a stronger degree in the crust, up in the ionosphere. And we are also seeing the geoelectric field, at least for the British Isles. We're seeing that increase in its power density. So there's just in general, like out of the quantum framework, this energy manifestation just exploded. Because what's controlling this? Or what's influencing this? Just as, for example, you have a plant and you shine a light on it, you'll influence it to grow because you have the light here that you're shining on it, right? What is influencing the sun to go through this big increase of energy, which then is reciprocally pushing that towards Earth? It's some greater potential within the quantum reality framework, right? You can read up on David Bohm and the implicate order, the super implicate order. It's really interesting stuff. But there's something that's manifested out of the quantum field to cause this energy just amplification. It's not occurring just here, it's also occurring with the Earth at this moment in time. And we really don't know where this goes, but we know that we have an impact coming in on the 31st or so. And so this is, even though it's been ramping up for a while and this is kind of a climax moment now, we know that we have another step up in just a couple of days with the new moon, which is all about new beginnings. The new moon is this period of time where these things are set and you start a new cycle that goes all the way up to the next full moon of the same constellation or sign 6 months later. And so this all occurring at the very end of 2024, in many ways is reminiscent of what we had last year at the very end of 2023, because we had this big increase in solar energy too, which set the stage for the big solar activity that we saw this year. And now we have this new push of solar energy taking us to new heights at the very end of 2024, almost like it's saying, get ready for 2025. And in 2025, we have some insane planetary resonances. We have Saturn and Neptune go conjunct. We have Uranus change signs. This is signs, not constellations, signs. You know, Jupiter change signs. All the outer planets are shifting in 2025 in a big way, but really the Saturn-Neptune conjunction is the biggest. That occurs only once every 35 to 37 years. The orbital rotation of Saturn is 29.5 years. Neptune is Neptune is like 164. So it takes time for Saturn to catch up. So we have this synodic cycle of 35 to 37 years. We have that occurring next year and 2026 during solar maximum. It's going to be wild. We also, it's going to be a shit show. I almost put the title of the video, the sun has lost its shit, but I decided not to put that. So we also, though, have, let me show you this. If we want to go a little bit longer time perspective, this is important to talk about as well. If I can, it should be, here we go. This is a really great data set from some friends of mine in Hungary that run a geophysical observatory there. We're looking at the Schumann resonances. We're looking at sunspots. Here we have solar cycle 23, solar cycle 24. Solar cycle 25 thus far has been very reminiscent of solar cycle 23. They've been basically equivalent in strength thus far. And what we see here is that as sunspots go up, we start to see this increase in the frequency of the Schumann resonances with a slight time delay, about 12 months or so, about a year. And then that remains as the solar cycle starts to descend down. And so we see this very nice connection between a solar cycle and the Schumann resonances, which again are these energy fields which overlap with our consciousness and our body, our cells, our DNA. The more we research into them, the more they blow our minds, basically. They're created by the Earth herself, but again, fed by solar energy. Because you need the ionosphere to create these. And the sun is what generates the ionosphere by that solar radiative influence, creating plasma in our upper atmosphere. So we see this time delay between the Schumann resonances and the solar cycle. We're just about to start hitting this aspect as well, because we are charging up in solar cycle 25. We'll check out sunspot numbers in just a second. And then that occurs. Then we get that increase in the frequency, and then it takes some time for that to descend down. We see solar cycle 24 here, weak solar cycle. We didn't have as much a response in the Schumann resonances as a result, but solar cycle 25 has been strong, and therefore it's likely that we're going to get something very similar to what occurred back at the end of 23, which is the early 2000s, occurring this time around as well. Let's look at our sunspot numbers. Turn that on. So you can get a sense of how solar cycle 25 has stacked up to solar cycle 23 and also 24. And we just need to zoom out here. Let me pump that. Yeah, here we go. So here we have our solar cycle progression, and we're going to do a question and answer soon. So get your questions lined up, and then we'll go kind of back through the data again. Here's solar cycle 23, 24, here's 25. Looking pretty similar to 23. Perhaps we're even going to go push up even higher off of this number there. Our highest count for sunspots was 200 in August. We've been down below since, but right now sunspots are over 250, like the daily count. This is the monthly count. And if we go down to solar radial flux, then we can see the story here. Solar radial flux is in many ways a better measure of solar activity. And we can see that it looks a little bit more solid and staying elevated than, for example, sunspots. Because if we go here, it doesn't have as big of a decline as the sunspots did coming off that peak in August. August average value for solar flux is 245, average value. Right now we're at 260 and above, just the daily value. But we've been up there for about a week now. So this is where we are in our solar cycle. We are seeing energy increase on the Earth as a result of this. In the Schumann resonances, we've had some big earthquakes this month because we had that dip in solar activity, and now it's exploded back up. And so one question I have is, okay, when we have our next dip in solar activity, it will occur at some point. When you have that next one, what sort of Earth energy events are we going to have as a result of that? Like earthquakes, volcanic eruptions, that's a big question. Look at this. Let's check this out. Because this is pretty wild. We have some insane planetary geometry coming up in 2026. We also have some significant geometry coming up in 2025, but not as much. Oh, Actually, I don't think you can see this. Let me, yeah, I have to move this over and then I can change the display. One moment. We are going to look at the planetary geometries that are active coming up. I guess you can see all this stuff happening right now. Let me switch this over. Yeah. Let's do that for now. There we go. Come on. There we go. Okay, here we have our solar system. This is Solar System Scope. This is a program which allows us to look at the relative position of the planets and across time. Here is what's active right now. We do have some geometry that's at play. You'll notice this Mars-Pluto opposition. That goes exact again, I believe, on January 6th, but early January. And we have, if we go forward a little bit in time, thank you for the super thanks, Blue Sky. If we go forward a little bit in time, here we go, we will see some, kind of significant planetary geometry coming up here in March. This is March 21st I have set. We see the Earth, Venus, and Sun, Earth, Venus, Mercury, and the Sun all in a nice line with Neptune and Saturn on the other side. And so this is the most significant planetary geometry we have in 2025 that I found, this alignment here. And these two will basically go conjunct in July. I think it's July of next year. So we could have some kind of significant events occur around this time. D1GGO, thank you for the super thanks. That's awesome. Looks like we might have clear skies in southern Finland for the first time in several weeks. Just in time for the CME impact. He's totally hyped. Thanks for everything that you're doing. Yeah, you will very likely have some great aurora come in at the very end of the year to bring in the new year. So jealous of where you are in Finland. I've been to Finland once. I visited Helsinki. Was it Helsinki? We're on the other side of Estonia. I'm blanking right now. But yeah, very nice people there. This is what we have for next year. Let's look at the really significant planetary geometry at the beginning of 2026. This is where things get kind of wild. And, if I set for January 11th, it shows up basically pretty nicely. Actually, I think I can go further back. Yeah, so here's the planetary geometry that we have for the beginning of 2026. This is early January. Here's Mars, Venus, Mercury, Sun, Earth, Jupiter. Now you have basically all the inner planets and the Sun and the biggest outer planet closest to us, Jupiter, all in a perfect alignment. And when you have alignments like this is when you kind of have to watch out. It's not guaranteed that this is going to trigger something. Not guaranteed. But that is definitely something I'm watching closely, and I wouldn't bet against this planetary alignment doing something significant in terms of solar activity or in terms of earthquake activity, or both. I wouldn't put money against this. Doesn't mean it's going to occur. I'm not going to be someone here saying we're going to have exactly this occur and the world's going to end, because a lot of dumb people on YouTube do that. I don't know why, but whatever. I'm not going to say that, but I wouldn't put money against this triggering something energetically with the Sun or the Earth. So that's coming up early January. If you have any questions, please shoot them in the comments below. Type @StefanBurns. Let's start rolling through some questions, and then we'll get back to looking at the Sun. And at some point, I will sign off. So, but happy to be here to support you all. And yeah, thank you all for being part of the live stream. It's been fun so far. I see that's been super active, so that's great. I love it when we get a really active live stream with a lot of people. And it's a place for us to all come together and talk about these things, because that's really, really cool. So let's put our imagery back up again. Do we just have another M flare? I think we just had a, yeah, okay. Yeah, just nonstop. So again, if you have a question, at Stefan Burns, I'll do my best to answer them. Please keep them on topic and not super individual, like tell me something about myself. Let's focus on what's happening collectively. Thank you so much. And getting everything set up here to be nice. There we go, look at that. Earthquake in Taiwan. Okay, I can check it out. Let's see if it's a big one, though. It's probably not that big. No, we haven't had anything big for earthquakes. So let's go back here to our latest and greatest. Okay, we got some questions rolling in. Great. Do you know why we didn't get hit by the solar flare on Christmas? That is a big question mark. I don't know why that did not hit us. If we want to go with the most mundane explanation, it's because it passes south of us. And we did see most of that plasma density go to the south of our planet with the coronagraph imagery. But there was this push out above, and so it doesn't really make sense that we had almost no effect from that. We could have just gone lucky and slipped through some sort of void in the kind of the solar wind in general. But with the amount of flares that we had, even going back to the 20th of December, and the fact that none of them hit us is just bizarre. It's just bizarre. I don't have an answer for you, but it's just bizarre. I think it's more bizarre than just coincidence. So that's all I can say. Because I'm definitely, I don't know everything, and people that say they know everything are not being truthful with you. Have I heard the Blue Brain Project with 11 dimensions of consciousness? No, I have not heard the Blue Brain Project. Sounds crazy. Yeah, if you like, you can share more info on that in the chat. Can this cause an upset stomach? Yeah, so the bioelectric system and the autonomic nervous system really strongly is connected to your gastrointestinal system, the peristaltic rhythms, because this is your main energy source, basically. You receive energy through digestion. And everyone knows that when they're stressed, right, it can cause upset stomach and everything of that nature. And when you have a fight or flight response, that stops digestion, basically. And when you're in a nice, restful, parasympathetic state, your digestion improves. So when you have changes to your autonomic nervous system, yeah, that can definitely cause stomach upset, gastrointestinal problems, things of that nature. National Weather Service has predicted 20 through 30 foot waves for California, December 29th. Searchable headline. Yeah, California's been having some crazy wave activity, not only like Central California and NorCal, like San Francisco and Santa Cruz, but also where I am in San Diego. We've had some big waves and kind of unknown why, some sort of activity in the Pacific, I guess, creating this. We haven't really had any strong winds, at least here in San Diego, to cause it. Do you think we will have... Okay, that doesn't make sense. What might something look like, not end of world, but days of darkness? We have a car alarm going off. Apologies about that. Well, I'm not necessarily someone that subscribes to the end of the world hypothesis or days of darkness. So I can't really give you an answer there. I mean, we have 3 days of darkness with the December solstice in the Northern Hemisphere, when you have the sun appear the least amount in the sky and you have the most amount of light or night. So I think that in many ways is a reference to like 3 days of darkness is actually December solstice. Is the Schumann resonance still 7.83 hertz? That's the average. There's a variation of the Schumann resonance foundational mode across time. It has its normal kind of diurnal variations, 24 hours. Also changes, as we saw, across the solar cycle. A lot of solar radiation coming in from a strong solar cycle. It subtly increases the frequency. But the foundational mode won't go from 7.8 hertz to 20 hertz or anything. That's a different mode. The frequency range of the foundational mode is 7.2 to 8.8 hertz, basically. And it's really most precise. That's the band. That's the band that it occupies. The most precise peak power frequency is about 7.7 to 8 hertz, maybe 8.1. So those are the variations that it has. These are subtle changes in the peak power frequency, and the entire band is about 7.2 to 8.8 hertz. So it's never always just exactly 7.83. That's the average that's been calculated for certain locations looking at long time frames, 10 years, 20 years of data to calculate the average frequency. But it's always changing subtly, not dramatically, but subtly. Can you cover the pole shift topic that everyone seems to be talking about now? We can touch on it just briefly. I don't want to get lost on this. I'm actually going to make a video. I'm in the process of making a video on that. It was going to be released today before this occurred. But we can talk about it just a tad because, well, terminology matters. And so we have Google Earth here loading. And let's see if I have my right project pulled up. Yeah. Here is Earth's magnetic field. Well, here we have the Earth. Here's the Earth, nice and round. Here's the Earth in Google Earth. And let's actually collapse that too so it looks a little better. And let us find the location of the North Magnetic Pole. And let's kind of zoom this here. Yeah, so here we go. And apologies for any wackiness of Google Earth. When you're in the Northern Hemisphere, like in the Arctic Circle, it can go a little wild. But here we have the latest location of the North Magnetic Pole according to NOAA. The World Magnetic Model for 2025 was released. That's the location right there. Here are the next 5 locations that they predict going out to 2030. So we see this movement in the North Magnetic Pole. Again, I'm going to make a more in-depth video on this very, very soon. Let's look at the previous model locations. We see this is the previous model location for 2025. So they weren't exactly accurate, but they were close. That's the most accurate location for the North Magnetic Pole that we have right now. That's what they had back a few years ago. And here we see 2020, 2015, and 2010. So you'll notice the distance between these 5-year chunks is greater than the distance for this 5-year chunk. That's the first thing to keep in mind. And now let's turn on the observed magnetic North Pole locations. These are the actual measurements with a dip needle compass. Going back to the early 1900s, even late 1800s here. We see this movement. So that's pole shift. The North Magnetic Pole has been moving. It hasn't been static. Now, it's always been moving. The North Magnetic Pole is always moving around, even on a daily time scale. You measure it one day with a dip needle compass, it's going to be slightly different the next day. And then you take that average to get the pole location for, in general, that year, let's say. But there's been this acceleration, or rather there was this acceleration of the North Magnetic Pole starting about 1990 or so. We zoom in and we have 2001, 1984. We can go to our measure tool right here and, oh, I'm clicking, that's funny. So we have 1984 to 1994, 150 kilometers. Okay. And then if we go to the next one, it is 515 kilometers total. So, I don't like the measure tool on Google Earth. Sometimes it's a little off. 358 kilometers from 1994 to 2001. So pretty big acceleration there. That's 7 years, 360 kilometers. This one was 10 years and it was less than half that. So we had this acceleration of the North Magnetic Pole recently in time. And that has triggered a lot of conversation. One of the terms is used pole shift. The pole's shifting, right? There's also pole flip or pole reversal. Those are other things. If you go to 2010, we see right there over 5 years, 269 kilometers. If we go to 2015 to 2020, we have 242 kilometers. So we see already a reduction in the yearly movement of this North Magnetic Pole. So the acceleration's less. Accelerated a lot from 2001 all the way to 2015, and then started to deaccelerate slightly, the derivative of velocity, right? Then if we go to 2020 to 2025, we see it's only 210 kilometers. So it's been moving less and less and less per year. That's 210 kilometers. And then if we go to 2025 to what they predict, only 172 kilometers. So the magnetic pole has not been accelerating over the past 5 years. As a lot of people have said, it's actually started to deaccelerate. That's very important because if we were in a magnetic pole reversal, you would expect that to continue accelerating. Doesn't mean it can't happen in the future, but you expect this magnetic pole to actually start going, like 100 kilometers per year, 200 kilometers per year as it starts to go like this. Now, as we move, if we go further, where is the North Magnetic Pole right now? You'll actually notice that it's basically perfectly in the Arctic Circle. So there's a lot of people out there saying, hey, we're in the middle of a magnetic pole reversal right now. Meanwhile, the North Magnetic Pole is actually almost perfectly situated at the top of our planet. Now, has it moved a lot? Yeah, it's moved over from Canada to Siberia. Maybe there's a reason why. But I would not at all say there's an excursion occurring until we pass the Arctic Circle. We have that line right there. Once the magnetic pole is kind of on the other side of the Arctic Circle, and even maybe like a line below that, because here we see it was fairly close to the Arctic Circle, right? Late 1800s, early 1900s, it was close to it on the Canadian side. Once we're below the Arctic Circle, then we start to have a little bit more of a conversation as it relates to a excursion. Maybe even this latitude line right here, which I think is like 30, but something like that. But until we are out of the Arctic Circle, we really can't be having the conversation definitively of like we are in a excursion, pole flip, reversal, the world's going to end. Those people are just selling you lies and they don't know what they're talking about. Because this is where we are right now. Now, why are we there right now? Let's give that a look. The best explanation, doesn't mean it's right, but probably is, the best explanation is because we have these flux lobes. The magnetic pole in the northern hemisphere actually splits into two, bifurcates. We have an area of greater strength in Canada, then an area of greater strength in Siberia. And what's occurred over the past 50 years is the Canadian flux lobe has actually diminished slightly as the Siberian one has strengthened. And as a result, the expression, the vertical, exactly vertical magnetic field expression at the surface, we're just measuring this at the surface, right? The magnetic field goes all the way down in the mantle to the core, all the way out to space. This is just at the surface, has shifted from the Canadian one closer to the Siberian one. And now what we're seeing in the past 5 years is that as it's started to enter into that Siberian flux lobe zone, it's actually started to deaccelerate. It's not accelerating anymore. It accelerated a lot here. Now it's deaccelerating as it reaches that Siberian flux lobe. Now the thing that I'm really looking at closely here, and I'm not saying this to scare anybody, is that it's actually moving right now basically towards a supervolcano. So we have the Gokul supervolcano here at the very end of Gokul Ridge, which is the northernmost part of the Mid-Atlantic spreading center, spreading ridge, right? We see a Gokul Ridge right here, and then it peters out. We can actually see that with our bathymetry data, how the spreading ridge peters out and this ends in this big caldera. And they just recently discovered this, 1999. And then I think the paper that identified this as a big volcanic explosion caldera was 2014 or 2016. I think it was 2014. This is 3,000 cubic kilometers. And we have certain data that indicates that this is from a volcanic explosion. We have magnetic susceptibility and remnant magnetization intensity measurements that pinpoint this as 1.1 million years ago, in addition to the actual spreading rate, because there is a very slight spreading ridge at the bottom of this caldera, moves about 0.6 6 millimeters per year. And that gives us an age of about 1 million years. So we had a massive supervolcano explosion 1 million years ago. Now we know this system is still active to some degree. We don't know if it's supervolcano active, but we know it's still active to some degree because there has been recent volcanism and earthquake activity there. Here is the overlay of that. We have these zones there are where we've had recent earthquake activity. In 1999, very significant seismic swarm that resulted in 3 new volcanoes on the bottom, Odin, Loki, and Thor. And they saw pyroclastic flows at the bottom of the ocean as a result of that volcanic activity, which is very, very, very unique, never seen anywhere else. It indicates a very high CO2 concentration, greater than 13%, which is an order of magnitude higher than typical CO2 dissolved concentrations in magma, meaning it's extremely explosive. And then in 2018, we had a seismic swarm as well in this zone. So we have the old supervolcano caldera here, a million years ago. We have the new seismic and earthquake activity and volcanic activity that's occurred in the past 20 years here, about 25 years. And North Magnetic Pole is moving exactly in between that. As of right now, the trajectory has it passing right through this supervolcano system. So that's the thing that has my attention more so than like a geomagnetic excursion, because again, we see that the movement of the North Magnetic Pole has actually been deaccelerating. This is just one of the magnetic poles. We also have the South Magnetic Pole, but I don't have that data yet on this Google Earth data set that I've been creating. So we know that in general, the South Magnetic Pole, it's roughly here. Is that right? Let me zoom out. Everything's flipped. South Magnetic Pole, yeah, it's like roughly, I believe it's like here-ish. It's just now starting to move off of Antarctica. But again, if we put on our Arctic Circle or Antarctic Circle, it's still in that zone. So pole shift, yeah. But people use pole shift as pole flip, and pole flip is a totally different thing, and that's not something that we're in right now, that we know of. We can't make that statement. So a long answer to your question. Sorry, everyone that also asked questions. And thank you for all the super thanks that came in during that time frame. But yeah, debunk the fear-mongering fools. Well, yeah, it's just, there's certain things that you kind of need to have certain conclusions, and we haven't had them yet. So yeah, I'm going to be making a more in-depth video on that, but I know that a lot of people have that question, and we have the audience right now. So it was good to go through it. Just also want to, let's look at our sunspots, see what's been happening here. And then again, if you have a question, at Stefan Burns, and we will go on it. The coincidence of the Parker Solar Probe flyby on Christmas Day and the sun's wacky behavior. Yeah, it is interesting how we have this probe get closest to the sun, and then all of a sudden the sun starts to go kind of nuts right afterwards. Here we have sunspots from the Gong network over the past, I don't know, about 3-4 days or so. Let's see how far back this goes. Goes back to 26. We see them now all perfectly rotating through that Earth center zone. The growth on this guy. 3938, soon to approach strike zone, and they're going to start rotating out now. So the question is, how many more do we have coming in? We looked at that far side data. It looks like there's 3 sunspot groups that have appeared on the far side spread out. They're not all going to enter at once, but that is the case. What sunblock do I use? I don't use sunblock typically. From RGB, you're always such a bright light with helpful info in both the physical and spiritual arenas. Keep up the great work. Thank you. Thank you so much. Blessings, the accelerated pole move is like a compressed spring. When it is released, it will shift quickly. We'll see. The geologic evidence indicates that typically it takes a few thousand years for there to be an excursion. And then a pole flip occurs when that now with the magnetic fields have flipped, they have to stay flipped for like 2,000-3,000 years before it then locks in and you have a reversal. Because there's times where you have an excursion, it stays there, and then it goes back. It kind of rotates through like this, and then you actually don't end up flipping polarity. The past excursion that has the best data and very clearly stands out in the record was the Lechamp excursion. There's been some others before and since, but they were much weaker in recent history. 42,000 years ago, the Lechamp excursion, that sticks out like a sore thumb in the magnetic intensity and the direction vectors of the magnetic field across the world in lava flows and different things. Whereas the other ones, it's like they'll find evidence in one spot, but they don't find it anywhere else. Lechamp excursion, that was almost a geomagnetic reversal, did not occur though, did not cement in place. Does this pole speed line up with solar intensity? Not really. The Earth's core has stopped spinning. That's another piece of kind of bad reporting. I'll go into as quickly as possible. We have these seismic measurements of the inner core and the outer core. And we are able to measure, in general, the rate of rotation of the core as a whole. And it's spin like this. And what we notice is that there's these oscillations of the inner core where sometimes it is rotating faster and then it decelerates, but it's always rotating in the same direction. It's always rotating like this, but sometimes it's rotating like this faster and then slows down faster and goes like this. That's one explanation. We also know that the inner core is anisotropic, and so it has irregularities basically. That's what that means. It is not perfectly spherical. There is selective melting on one side of the inner core and selective crystallization on the other side of the inner core. And all we're looking at are these sound signals, these seismic waves that are propagating and hitting and reflecting back. And so there's two explanations that could both be accurate as to what's occurring with the inner core. It could be A, that there is selective melting and crystallization that's occurring that's giving the impression that there's this change in the rotation of the inner core, or it could be that the inner core is actually changing its rotational speed, but it's not actually going backwards or stopping. It's just either speeding up or slowing down along its normal rotation. But again, it could also be we're noticing these differences because of the anisotropic characteristics of the inner core. So if you read the research papers and you read a few of them on the inner core, you arrive to that conclusion. We don't know which one it is or whether it's a combination or something else. But the headlines, you know, they overly simplify and they want you to kind of freak out. So they say the core stops spinning. That is not accurate. Can you talk more on Earth's magnetic field protection being reduced every year over 5% for the past decade? Yeah, that's not accurate either because we have different magnetometers not only across the globe, but also now in space that have been measuring Earth's magnetic field. And that's just another data number that's been thrown out by certain people that isn't actually based on the data, right? They're just making up numbers. So for example, the magnetic field in Scotland is the same strength, it's actually slightly stronger than it was 150 years ago. We have these changes in the magnetic field strength that occur across time, these secular variations. Sometimes we get big pulses of increased magnetic field strength, like for example the Levantine Iron Age anomaly, or the Western Europe magnetic pulse that we had back around like 1000 AD. And then we've had some increases kind of since then. That's all going to be in future videos I'm going to make. I've talked about it before as well. We have seen in general Earth's total magnetic field decrease about 10% since 1850. And we are seeing secular variations in the magnetic field in certain spots across time. The South Atlantic anomaly has weakened a bit. Other places have gone a little stronger. For example, like the Siberian flux lobe is actually strengthened. Again, I reference, Scotland. They have measurements going all the way back to 1850 when we first developed our ability to measure the magnetic field on an absolute scale. Thanks to Gauss, the Scottish chap who actually developed this. And that field strength has stayed stable for 150 years. So has it gone down 5% every year for the past decade? 50%? No, it has not. The field strength right now for Earth's magnetic field is about 23,000 nanotesla to 63,000 nanotesla, depending on where you are. At times it's been stronger, at times it's been weaker. I know there's a lot of questions in here. Is the deceleration of the magnetic pole recently a good thing or is it a negative thing? Well, just to quickly just to quickly go back to our Google Earth here. It's hard to say. Do we want the magnetic pole stopping right over a supervolcano or hanging out in this zone for a while? I would say no, because we have the magnetic pole in the northern hemisphere actually acting as a funnel for this type of solar energy that's going to be coming in, right? We have solar ions from the sun get launched with these coronal mass ejections. They flow down the field lines and they get deposited into the Earth in this general zone, in the auroral zone, right? So if we zoom out, in this general zone right here, but really specifically, they're going to funnel down where the field is vertical. And so if we get the magnetic field to stop right in the supervolcano zone here, best evidence indicates that this is still an active supervolcano. It just doesn't erupt that often, every million years or something like that. But if it's to stop there or like transit through very slowly and you just get more energy being pumped into that zone, what does that do? That's a big question mark. We don't know if that's going to do anything. It's very likely not to. On the geologic scale, it'll probably pass through harmlessly. But if I had to, if I was the creator god, I would be like, no, let's avoid that, okay? Let's like route around that. Like let's not drive through the blizzard, right? Let's not walk through the volcano, basically. That's something you would want to avoid. It's just a higher probability, I would imagine. But we just don't know that much about this. But this is what's occurring. The magnetic pole is moving through the supervolcano. And so it deaccelerating may not be a good thing. We may actually want to prefer it if it's not just going to stay here. We may want to prefer actually going through the zone quickly and then reaching the other side and then stabilizing. But we don't choose. Good or bad, it's hard to say. Have you heard the story of Chris Bledsoe and the predicted upcoming Ascension Revelations event on Easter 2026? No, I know you're talking about Chris. He recently, or I think he will be soon, on my buddy's podcast, from Matt Bell, the Limitless podcast. But a lot of people have predictions for a lot of things, and 99% of the time they don't come out true. I read that we are moving from an age of winter to an age of spring. What do you think? We're going from, I don't know exactly what you mean. There's a few different ages that we are in. We're entering the age of Aquarius. We're out of Kali Yuga. And just in general, we just had our December solstice. We are in a grand maximum for solar energy, interglacial period, right? Where we've moved out of a glacial zone. Now we're in an interglacial period. So there's a lot of different kind of things occurring all at the same time. Do you remember Professor Dr. Valentina Zarkova? Yeah, the name rings a bell. What is my feeling on Cascadia and Shasta? Are you feeling something bigger coming? Well, let's zoom in on that. Cascadia and Shasta. Mount Shasta is in California. It is a stratovolcano. This should be it right there. And at some point it will explode. There's a lot more of those in Washington, as you can see. All these little white spots there are stratovolcanoes. They're the more explosive ones that just suddenly go boom, like Mount St. Helens. That's Mount Hood right there. Do I think something's going to occur with them soon? I mean, I wouldn't put a date down and start betting on it because we just don't know. We have had quite a bit of earthquake activity here recently with that magnitude 7 right off the Ferndale and on the San Andreas, at the very end of the San Andreas. But is there a big subduction quake coming with Cascadia soon? Hard to say. A lot of people like to say, is a big one coming soon and make a big deal out of it. We had a magnitude 3 earthquake, the big one's coming. Magnitude 3 is nothing. That magnitude 7 is the biggest one that we've had in a while. Biggest one in a while. But in terms of this zone there, I mean, who knows? Who knows? Just, it's always good to be prepared. It's always good to have a bug out bag. It's always good to have extra supplies. You don't need to hoard 30 years worth of food, canned food or whatever, but make sure you got, a couple weeks of food available. Some canned fish, for example, beans, some extra rice, all that stuff. Water, make sure you have water. Like I get spring water, so I get a whole bunch and I go through it over time. Make sure you have like ability to light fire, and it's always good to be prepared. I'm an Eagle Scout, be prepared. That's one of our mottos. Yeah, Ryan, Chris's son was already on. Exactly. Chris will be on soon. I haven't watched that podcast yet. So if you have any more questions, please drop them now. Otherwise, we're going to just do one quick examination and then I'm going to sign off and have my lunch. So thank you all for being here. And I don't know how the stats have been doing either with this live stream. Looks like a lot of people here, 2,700 concurrent viewers. That's awesome. Thank you all. Love you all. God bless. Just want to pull up our most recent, see if we still had a push with solar activity. Coffee and Stephanie. I had my coffee right before this. What about the super cold polar vortex coming in? Yeah, we have some pretty big polar vortices coming into the United States, more on the eastern side, beginning in 2025. And it looks like that we're going to have like a sequence of those. And so if you're on the eastern, if you're up north and on the eastern half of the United States, then definitely make sure you're prepared for that. Extra gasoline, right? If you have your own home, maybe a generator, but everyone can do what they want to do. Here's our X-ray flux. That's that 1.11 X-class flare. Then we've had all these M-class flares, more than probably about 20 M-class flares or greater in this period of time right there. Not even 24 hours. Does solar activity lead to tornado activity? Well, solar activity in general will enhance the global electric circuit. Will that directly lead to more hurricanes or tornadoes or weather storms? Directly, no. But when you have a stronger global electric circuit, that enhances the gradient, the electric field gradient running from the ionosphere to the ground surface. That's been shown to alter, for example, like water dynamics, water electrodynamics in the atmosphere and lead to ice condensation. And it changes quite a few things actually as it relates to the atmosphere, humidity, pressure, and that again is what leads to weather. That's a very important component of weather systems. So yeah, when you have a change to the global electric circuit, you have some sort of change to weather systems on the surface, but you can't exactly pinpoint it directly and say it's exactly that, it's exactly that. But there is a system there. And so in general, when you get this amplification due to solar activity, you can expect there to be more severe weather. Doesn't mean it's going to happen, but you can expect that. Quite a bit of earthquakes in Ethiopia near a string of volcanoes. Is this normal or a cause for concern? Thank you, Haji. Actually, this is interesting. Let's go to latest earthquakes by USGS. We can go to 30 days, magnitude 4.5, and let's zoom over to Ethiopia. Look at that. Here's a whole bunch. 4.7, 4.9, 4.5, 4.9, 4.8, 4.5. So yeah, a lot of earthquakes right now, right here in this rift zone. You have to keep in mind, the African continent is rifting apart right here. A new spreading center is being created through that continent. And here's something that I think is really interesting. Let me pull this up. You guys will like this. I just have to find the right one. Should be the secular variations. Oh, is this inclination? Yeah, we don't want that one. In the total field strength. Yes. So let me push this over now. So yeah, all these earthquakes for Ethiopia over the past 30 days. Now we are looking at our magnetic field that was just released, 2025 World Magnetic Model. And we are specifically looking at the secular variation, the annual change. Here we have the magnetic field getting stronger, the total intensity by 100 nanotesla per year, weaker by 100 nanotesla right here. Look at that zero line. This basically is forming like a magnet right here, right? These are two poles of like a magnet effectively. And that zero line is right on that Rift Valley, right there along that Rift Valley. So this is something I'm going to be researching into more, but that's very interesting how the biggest secular changes that we have occurring with the total magnetic field, basically for the entire globe. We have another negative, pretty significant drop there over North America. But this is by far the most interesting, obvious feature in terms of the changes in the total intensity of the magnetic field at the surface. The center of that is exactly on that Rift Valley where we are having all those earthquakes at this moment in time. Ethiopia just slightly to the north of all that activity magnetically. So yeah, you can kind of overlay the two. Very interesting. What does that mean? I think perhaps that just means that there's going to be there's greater activity right now with that rifting zone. But this is a long geologic process. This is something that's going to unfold over millions of years until this creates effectively a sea like we see there, right? This is also a rifting zone here. We have active rifting here, creating the Red Sea. And then if we go even closer, we have these guys. I've been right down to here. Or I was right here in Eilat in Israel before. But we're going to effectively have a sea open up here as well. That's going to rift off. This Horn of Africa will push off like that. How much do you make off of a live like this? It depends. Depends on the super thanks. You know, enough for me to want to do them. But I also just do this because you know, I'm a repository of a lot of this knowledge and expertise, and I know that there's an increasing amount of people that are really, really, really interested in this stuff, and they want the truth. I can't claim I'm, you know, the one carrier of the truth, but I do have a prerogative of always getting as close to the truth as possible. That is a central focus and objective, is like, what is the truth? And then let's work from that, because one of the problems in our reality right now is that there's so much distortion and that we're not living in alignment with the truth and reality. And so that's what I'm most focused on, is even if the truth is difficult, what is the truth so we can go forward with that? Thank you, Divine I, for the super thanks. Also, thank you, Lady McBasin for the super thanks as well. So yeah, interesting stuff happening right now. Some other questions. Is the sun actually flipping its poles? It takes some time. That's the entire solar cycle. It doesn't happen instantaneously. It does take some time, but yeah, the magnetic field of the sun is flipping at this moment in time. We've had a little bit of that now since. I have some data for that. I think I can find it here. But regardless, it's a process. It takes some time. It's not a one-day thing. It's like a 3-4 year thing, right? The entire solar cycle is about 24 hours. And actually, that's not going to pop up that easily. Let's go to our forecast and see if they've said anything. I don't think they've actually released an update since this afternoon. Yeah, okay, so that's still the same way it is. Yeah, here we go. And just to see if there's any other questions. Okay, I think that is about it, folks. So thank you all so much for watching. We went way in depth on everything. We have a big power wave right now pushing through the Schumann resonances. We saw how that's occurring not only out of Tomsk, but also out of Italy and in the British Isles. And then we see this big push of energy coming out from the sun. We do have a question, another super thanks from Lady. Thank you so much. Is there a Planet X or twin star primer field? That is a good question. we have evidence of something organizing the outer solar system in the Kuiper Belt, all the different dwarf planets. A lot of researchers think that it's a planet X at about an orbit of about 200, 250 astronomical units, but it could be a binary star. And the binary star, it'd be ultra wide, and it's very likely to be a dwarf star, a brown dwarf. But if we even go beyond that, we might not have a binary star. What we've kind of come to realize is that there's a bunch of these brown dwarfs that are just floating through our local space and interstellar, space and the universe. And there's probably a more complex gravitational field that brings them in close at times and then they swoop away. And that could perhaps be this organizing influence. If you have a planet X at 250 astronomical units, it'll have a certain strength on the gravitational field, but a brown dwarf is much more massive, so it can be further out and still have the same organizing effect on these dwarf planets like Sedna. So is it a brown dwarf, binary star companion, ultra wide, or is it a planet X? That is open for debate. We'll find out. They're looking very fervently right now for Planet X, but they may not find it because it might actually be a binary star. I talk about that a lot in my Planetary Resonances e-course. I go super in depth on Planet X and binary star theory. So if you would like to learn more, then you can sign up for my Planetary Resonances e-course. You go to wildfreeorganic.com/store, or not /store, I think it's /e-courses. Just go to my homepage. You'll see e-courses, click that, you can sign up. That's where I go in depth. It's 15 hours of video content on the planets, their resonances and synodic cycles, and things like that, the astrological ages and more. We've had some more super thanks come in, so thank you so much. And yeah, thank you all so much for being here. Canadians, the tea blends I sell on Wild Free Organic are only available to those in the United States because shipping internationally costs too much money. So sorry about that. But the shoes are available internationally for everybody. Can these solar energies cause insomnia? Yeah, they can. They can definitely exacerbate that. Apophis asteroid swinging in close in 2029. What do I think? I think we should pay attention to that and give that a close look. Supposedly it's not going to impact us, but we know that for the public good, they probably wouldn't tell us if it would. But we have a lot of amateur astronomers who are also looking at these things. So it's going to make a close swing, but the probability of Apophis hitting us is very, very low. I don't like the name of it though. So yes, thank you all so much for being here, and I hope you found that all useful. I'll keep you up to date with everything that's occurring. Massive amount of solar activity right now. Looks like that's going to continue. Impact expected on the 31st from a full halo coronal mass ejection launched from a 1.11 angel number X-class solar flare. I think we got some more coming. The sun has just been boiling. We see that right here. It is wild. So again, subscribe to stay up to date on everything. I've been your host, Stefan Burns. Thank you all for being here.